height would be h bc. As for the depth, now the depth needs to go in this direction. I think it should be equal to the radius of the battery. As for this one, we need to subtract the terminal height and this connector height. So minus height of the terminal, then minus height of the serial connector, and then additionally we need to go height parallel connector. This should, yeah, so that would be over, but it needs to be a little bit more here, so we can do this one, subtract this and half of this maybe. Did one, but now also add this one here. Yeah, this looks good. Yeah, so that's fine. That's okay. Yeah, so that would be our parallel connector. Now, instead of creating each one of, we can just simply use the array command to transfer like this one block or in the x direction as well as in the y direction. For that, now in the x direction, we need two more, right? So in total, we'll have three. And in the z direction, we only need to copy this set of parallel connectors on this side. That will be like two sets, so you can just use two here. And now in the x direction, how much this needs to be moved? Probably that equal to the diameter of the battery in the x direction, and in the y direction, that would be height of the battery plus 2 times the terminal height, 2 times the height of the terminal plus 2 times the height of these serial connectors HSC, and plus 2 times the height of parallel connectors. This should give us 3. Sorry, we need to, like, in the input geometry object, we need to select this one. So yeah, but it is slightly above, right? So what we can do here is select this one maybe. Probably nope. Nope. So then, sorry, it's negative. Why it's negative? Yeah. So we need to go with this. Like this and put it here. It should do almost right. So let's check if the connection is okay. Yeah, the connection is okay. Yeah, that's great. So this will be our geometry, right? But we need one more thing, probably a few more, but in terms of geometry, we need one more. And that one more would be the domain of air that will surround this module, because in actual batteries you have the whole box thing, and inside you have batteries, and the free space is occupied by air normally. So we basically are creating air domain. For that, we can, instead of creating a block, we actually now need something more technical or more sophisticated. For that, we can develop a work plane, and this work plane needs to be at the bottom of this parallel connector. For that, right now we can move it like right minus height of the terminal, that would be below this terminal. Then again add another height of the serial connector, and additionally add height of the parallel connector. That would give us the plane where we want it to be. So here, now we need to build the profile of the domain on this plane, and then we will extrude this one to cover the entire thing. For that, you can simply select this like plane geometry, and it will direct you to the plane here. And here, add first of all a small circle, and the radius of that would be equal to the radius of the battery. And we only want this to be maybe sector, and let's rotate it by 180 degree, right? And another square, here we are. The height of the side length would be equal to the radius of battery, and again rotated by 180. That should do. Yeah, now add boolean variable like boolean partition here, and use difference. And in the objects to add, select this whole square, and in the objects to subtract, select just this sector here, and build selected. Now we have this one. Why we have this one? Create a rectangle. Now I want this rectangle to cover like the all three batteries. So for that, the width of that would be 3 times the diameter of the battery, and height would be simply equal to the diameter of the battery, like this. And just use this, but notice it won't be, yeah, it won't be where we want it to be. We want it to start from here. So for that, we need to subtract radius of the battery. So this is like we are moving this corner to this. So for that, we want it to go in negative x direction and then negative y. So that length would be radius of the battery, negative, basically, something like this. Now we want to create another Boolean variable to difference, share it like these two. So object to add would be the bigger object, and object to subtract would be this smaller subject object, sorry. Yeah, so that's what we want to extrude. This will be our air domain. And now simply just go here, geometry, and add extrude here, this one, and it will automatically give you the direction. So this is like the default direction, so you can just give the height up to which you want this plane that you just created, or this geometry that you want just created, up to how much you want it to go in this direction. So that would be the height of the battery plus 2 times the height of the parallel connectors PC plus height of the serial connectors plus the height of the terminal. So this will be the domain. Yeah, so that's our air domain, you see. And just to be have more clear visualization, you can actually select this like transparency thing, and this is your geometry. Now before we move further, there are a few things that are very useful that will especially help us in analyzing the results in a better way, and it will also help us during the whole simulation setup, and that would be selection. Now when we want to, let's say, name this only maybe this one battery as battery one, and we don't want to every time maybe point out select every single surface of it just to define this, what we can do is we can define a group of elements, and in COMSOL we refer to that kind of thing as selections. So we can select this explicit selection here, and we can just once select this battery like this, and maybe name it as battery 1, right? And then simply just copy this one or maybe duplicate. But one more thing, like before you do this, make sure this form union will select this is above the battery, so drag it, sorry, we can drag this, in fact drag the battery part below this, something like this. Yeah, make sure this is at the top. It's actually a good thing, just it kind of gives us the union of the entire thing. So we have battery 1, we'll select it, duplicate this one and name it as battery 2, and instead of this one you can select this like clear selections and select the second battery. Now as you can see, we can select this, right? So when you have your mouse on this second battery, scroll your mouse wheel and you will be able to select this one. Now press click. So that's your second battery, and now copy there, like duplicate this one and name this as second, instead of second, third, as third battery. Again go here, but we need to select this clear selection, and now you want to this to select this third battery. For that, again press your keep your mouse pointer on the third battery, scroll your wheel on the mouse, and then you will be able to select the third one. So these are like our 3 batteries. Select and press build selected. So these selections kind of helps us to define different parts of our geometry explicitly, so that later on it will be more easier to select them. Now imagine that I want to select these connectors. Now in later when I'm defining bounding conditions, maybe, or maybe I want to analyze results or something, I will have to select these connectors individually, which is like quite tedious thing to do, right? Every single time you have to do something with them. For that, we can define maybe this sort of explicit selection, so that I don't have to select them every time. I just need to select this selection that I just already defined. So before you do that, do one more thing. that is create an extra selection here, explicit selection, and name it as air domain. Now this will be our air domain. You can simply just select this one. So this whole thing, this box only selects the outer part other than the geometry, like these batteries and the connectors. So this will be our air domain, and build selected. So this is selected. Now create another one, another selection, but this time instead of explicit selection, select complement selection. What this does is that everything that you will select here, other than that, will be your like selection, like this will be that. For example, let's the best way is to actually do it. So I will be naming them as this selection as connector, and I will be adding these, and make sure you press control button on your keyboard and then select all of these four. These are basically what I already just defined here. So press OK. Now notice that selections to invert, meaning everything other than these. So other than these, like air domain batteries, you have these connectors, right? So this selection now refers to all the connectors. Now I don't have to select them individually every time. So this will like help me a lot in later, like when I'm setting up the whole simulation thing. And other than that, maybe we want to, let's say, analyze all the batteries together, right? So for that, you can go to union selection and name this as batteries. Instead of individual batteries, now let's say I want to group all three of them into one selection. For that, you can add and select these three. Press Control on your keyboard and click these here. And okay, so now these are your batteries, right? So similarly, add one more here. That would also be like union selection, and this time select these connectors and batteries, right? So let's say maybe at the result stage I want to analyze this and I don't want this air domain, so this will help me at that stage. And finally, add one last thing, that would be let's say explicit selection. Yeah, I think that should be fine. So what this is now, since I don't why I'm defining this, let's say I want to define this outer surface as the flux boundary condition, because when we are dealing with heat transfer, we normally need some sort of convection boundary or maybe conduction, something like that. So this selection will help me select those boundaries. So at this like geometry entity level, you need to select boundaries to make sure it only selects the surfaces. So those surfaces will be like this one, this outer surface, this one, and this small section here. And also notice that there is this small protrusion here as well. So we also need to select this one. So this will be like also a part of the convection boundary condition. And I also notice we have like this back, at the back we have another surface. So just keep your pointer here, scroll your mouse wheel, and you will be able to select this one like this. Similarly, this bottom one, mouse wheel, scroll that, and there we go. Also, let's just select these two as well at the back here. Scroll your mouse wheel, this one, scroll your mouse wheel, and this one. So this will be your, let's say, heat flux boundary condition. Heat flux, or maybe convection, let's say. Yeah, convection, that's actually better. Convection heat flux boundary condition, or boundary, so not condition, just the boundary. Yeah, something like this. So build select. So now you have all the like things that you need, right? That will help a lot in at the later stage of simulation. Now in this video, I only developed the geometry